velocity is the total displacement traveled divided by the total time. We can calculate the average velocity by simply finding the slope of a line. However, sometimes we don't have a line, we have a curve. So to calculate the average velocity of an interval in this curve, all you do is you find the slope of the line joining 2 points on a position time graph. So if I wanted to figure out the average velocity between these 2 points, all I would have to do is find the slope of the line that joins those 2 points. So that's V average. Now, instantaneous means at that particular instant. For instance, if I'm speeding down the road and a police officer points the radar gun at me and he clocks me doing 110 in an 80 zone, it doesn't matter that I slow down after I see him, or a minute ago I was going less than that. All he cares about is that particular instant. So instantaneous means at that specific point. So what we do is we draw a line that touches, let's say that's the point I wanted. I draw a line that just touches that point at that specific spot. That line is called a tangent, and we find the slope of the tangent. So V instantaneous is equal to the slope of the tangent, and a tangent is a line that touches the curve in one spot without crossing through it. So I want to give you a couple examples of tangents. So let's pretend I have a circle. If I were to draw a line like this, well, it touches the curve in one spot, however, it crossed through this. So this is not a tangent. I'm going to put N for no. If I had a line like this, well, now it's crossing through 2 points. So no, that's not a tangent. Another example could be if I draw this blue one here. Well, it's not even touching my graph. So no, that would not be a tangent. A tangent would be if I put my ruler down and line it up so it only touches in the one spot. So if I draw my line like this, where it only touches here where I'm interested in, that is a tangent. So a tangent touches a line only in one spot without, see how this one crosses through, so this is not, without crossing through it. So that's a tangent. And then you simply just find the slope of that line. So if I want the speed right here at this little red dot, I just find the slope of the line that touches that curve in one spot without crossing through it. So this is V instantaneous. Let's practice some examples. So I have this graph here, and it says determine the average velocity between 0 and 5 seconds. So I put a dot at 0, I find 5, I put a dot at 5, because average said the slope of the line joining 2 points. I now draw my line connecting the two, and I want to figure out the slope of this line. Well, I know that V average is equal to slope, which is equal to the rise over the run. I now need to figure out my rise and run. So it looks like I'm going from 0 to 140. That's my rise. So my rise is 140. My run is between 0 and 5. There's my run, so that's 5. So I'm going to go 140 divided by 5. And when I put that in my calculator, I end up with 28 meters per second. So my average velocity between 0 and 5 seconds is 28 meters per second. Now, it's changing. I was going a lot faster in the beginning, and then I slowed down, stopped up here, and then I started picking up back in the other direction, but the average is 28. Now, let's figure out what the instantaneous velocity at exactly 5 seconds is going to be. So at 5 seconds, I want to draw my tangent. So I'm going to put my ruler down, and I want to line it up so it just kind of touches in the one spot without crossing through it. Probably about there. And I move my ruler a little bit. All right, so now I want to figure out my rise and run for this line. Well, it looks like I go down to here. So I'm dropping from 200 to 50. So that would be 150, so minus 150. My run, it goes from here to here. So between 2 and 10, my run is 8. So my v instantaneous is equal to my slope, which is equal to my rise divided by my run. And in this case here, it'd be minus 150 divided by 8. And I just need to put that into my calculator. 150 divided by 8 gives me 18.75. Now, the negative just indicates I've turned around and went the other way. So up to this point here, looks like the rocket's going away from the Earth, and then it slowed down to a stop, and now it's coming back towards the Earth. So when you see a negative in physics, it actually means something. It means you've turned around and gone the other way.